So guys, let's take a sum. Let's try one question. X square plus 2x minus 3, x square minus 8x plus 7 less than equal to 0. We have to find x, guys. So try this. So the hint would be to factorize and use wavy curve. Okay, now let's see the solution, guys. X square minus 2, x square plus 2x minus 3. We can factorize it. We can write it as x square plus 3x minus x minus 3, x square 7 into 1, so it can be factorized as minus 7x minus x plus 7 less than equal to 0. So guys, the next step, taking x in the numerator, taking x common in the first from the first two terms. Okay, so x into x plus 3, taking minus 1 common, so it becomes x plus 3 upon in that from the denominator x square, you will take again x common, x minus 7. The last two terms taken minus common, x minus 7 less than equal to 0. So guys, taking x plus 3 out from the numerator, inside we are left with x minus 1. Taking x minus 7 out, what we are left with inside is, yes, again x minus 1 less than equal to 0, guys. Okay, now x minus 1 we can cancel, but if we are cancelling two variables, okay, we should make this constraint, we should apply this constraint that x minus 1 shouldn't be 0, otherwise it won't be defined. So x is not equal to 1. So x not equal to 1 should be excluded from the solution if it is there in the solution, if it comes in the solution. So in the next step, we need to solve this only, and we have to apply this constraint that x should not be equal to 1. Now we can use, there are 1 zeros, the zeros is x plus 3. Okay, so we will get minus 3 as one of the zeros. Now poles, the denominator linear factor is 0, so x equals to 7 is another linear factor, guys. So again, marking the rightmost interval by plus. Now 7, the factor is x minus 7, power is 1, which is odd, so the sign would change to minus. Okay, and here x minus x plus 3 is there. Okay, power is 1, so again minus is changed to plus. Now the question is asking for guys less than equal to, so we will take minus 3 to 7. Okay, so that would be answer. What about equality? So equality is valid for minus 3 only. The zeros will satisfy. Poles are never part of the solution, so we should cross them. So the answer is what? Minus 3, which is open, close. So minus 3 square bracket comma 7 open bracket x belongs to minus 3 to 7, guys. But here we need to exclude x equals to 1, because we cancelled out x equals to x minus 1, the factor in the numerator and the denominator. So x equals to 1 should not be a part of the solution. So we need to exclude by minus 1, because 1 is inside, 1 belongs to this interval minus 3 to 7. Okay, so that's how we can do. Let's take another example, guys. X upon 1 minus x less than 1 by x. Okay, now try this. So what should be the hint? Can we do it like this, cross multiplying 1 minus x on the right hand side and x on the LHS like this? X is cross multiplied here, 1 minus x is cross multiplied here. Or can we do it like this? We can take the entire term of 1 by x on the left hand side, so right hand side would be left with 0, and then take LCM and solve. Which method is correct, or are both the methods are correct? What do you say, guys? So yes, the second method is correct, first method is wrong. Why? The reason is, if you are cross multiplying x, you are assuming that x is positive. We can cross multiply positive value without changing the sign of the inequality. See, here it was less than, so again I haven't changed the sign. So I am assuming that 1 minus x and x is positive, but we don't know what x is. Okay, so we will avoid this kind of cross multiplication. Okay, sometimes in some questions it can be cross multiplied, but then we have to make assumption also that 1 minus x is positive, x is positive, and so on. Then we have to take two case and we have to solve. As of now, this kind of cross multiplication of variable from one side of inequality to the other side, we shouldn't do that. Okay, so the second method we will do, we will take LCM now and we will solve it. So taking LCM, x we will multiply here, 1 minus x is multiplied here, and 1 minus x upon x. Okay, less than 0. So x square minus 1 plus x upon x, 1 minus x less than 0. Now as you can see here, x square minus x square plus x minus 1. We need to factorize this. Okay, so we will factorize this by using Sridharacharya or quadratic formula, because solving it by factorization won't be possible, because 1 into 1 nothing, we can write it like this. So minus b, so we will use the quadratic formula, which is minus b, a is 1, b is 1, c is minus 1, minus b which is minus of 1, b square which is 1 square minus 4ac, 4 into 1 into minus 1 upon 2 into a, 2 into 1. So the two factors are minus 1 plus minus under root 1 plus 4, it becomes upon whole upon 2. We will get minus 1 plus minus root 5 by 2. Okay. Root 5 is approximately equal to what, guys? Root 5 is 2.25 approximately. So the two factors are x equals to -1 minus 2.25 by 2, 2.25, taking minus sign and then taking plus sign, 2.25 by 2. So this is minus 3.25 by 2 minus 1.25 by 2. So guys, 1.25 by 2. So x is approximately minus 1.2 ones are 2, 116.62. Okay, and here it is 0.62. So guys, the factors of this, so the factors, we can rewrite it, guys. The factors of x square plus x minus 1 would be x plus minus 0.62 into x plus 1.62, guys. Okay, and we will take minus 1 common from here like this. Okay, so we will take minus 1 common from here. 1 minus x, so this becomes x minus 1, guys. So what we will do, we know wavy curve, we have to ensure the coefficient of x to be what? To be positive. That's why I took minus 1 here. Now what next we will do is, guys, we will multiply by minus 1 both sides. Okay, so if you multiply by minus 1 both sides, x minus 0.62 x plus 1.62, this minus and minus gets multiplied, it becomes minus 1 square, and the sign less than 0 becomes greater than 0, guys. Okay, now we can plot the zeros. The zeros are x minus 0.62 equals to 0, x plus 1.62 equals to 0, so x equals to 0.62, x equals to 1.62. The poles are, the first step, x0 and x minus 1 equals to 0, which is x equals to 1. So I will plot the zeros and poles on the number line. There are 4 values. The biggest of them is 1.62, as you can see. The least, the after that it is 1. 1.62 is cross. After that it is 0.62, which is again cross, which is a pole. Then 0. So writing plus minus plus minus plus. Now we have to find, the question is asking for greater than 0, guys. Okay, the question is asking for greater than 0, so we will take plus sign. It is like this. And this plus and this also. Okay, this followed by this. So minus infinity to 0. Now equality, it is not there. The question is not asking for equality. It is asking only for greater than 0. So we will take, we can write this x belongs to only plus value. We will take minus infinity to 0 followed by 0.6221 followed by 1.62 to infinity. So that we can write it as our final answer, minus infinity to 0 union 0.6221 union 1.62 to infinity. Now we can again rewrite it, minus infinity to 0. 0.62 was what? It was minus 1. 0.62 was minus 1 plus 2.62. 0.62 was minus 1 plus root 5 by 2. Okay, and minus 1.62 was minus 1 minus root 5 by 2. That we will replace it here in the final answer. Okay. Belongs to minus 1 plus root 5 by 2 comma 1. 1.62 will replace by minus 1 minus root 5 by 2 to infinity, guys. That way we will do. Let's take another example, guys. X square plus 4x plus 4. Just a minute, guys. So try this example, guys. So the first hint, as I in the previous example we discussed that the variable linear factor, like here if it is x minus 1, can we cross multiply it here? And in similar we discussed that we cannot cross multiply this variable, because we need to assume then that x minus 1 has to be positive, or negative, then we can change the sign. So the best thing, as I suggested in the previous examples, that the hint is to take this on the left hand side and take LCM and solve. That's the hint. So now let's discuss the solution, guys. So taking x plus this 6 upon x minus 1 on the left hand side fully, we are left with 0 on the right hand side of the equality. Now we will take LCM, guys. So taking LCM of the denominators, Okay, so all the three factors x plus 1, x plus 2, x minus 1 will come. Okay, so 3 would be multiplied with what? Yes, 3 would be multiplied with x plus 2 and x minus 1. So 3 gets multiplied with x plus 2, x minus 1, guys. Similarly, 7 would be multiplied with x plus 1 into x minus 1, and minus 6 would be multiplied to what? Yes, x plus 2 into x plus 1. X plus 2 into x plus 1, guys. Less than 0. So, guys, simplifying the first, this thing, x plus 2, x minus 1. If you see, if you multiply them, you will get x into x, x square. Then x is multiplied, this x is multiplied to 2, you will get 2x. Minus 1 is multiplied to x, you will get minus x. Minus multiplied to 2, minus 2 you will get, okay, plus 7. Now we will multiply x plus 1 with x minus 1. We can use a plus b, a minus b, guys. So we will get x square, a square minus b square. Directly we can write x square minus 1. Now the next is this x plus 2 into x plus 1. So x plus 2 into x plus 1, x square, x into x, x square, x into 2 plus 2x. Then 1 into x is plus x. Then 1 multiplied by 2 is plus 2. Okay, this whole upon these three factors, x plus 1, x plus 2 into x minus 1, guys, less than 0. So in the next step, x square minus 2x plus minus x will become what? It becomes plus x minus 2 as it is, plus 7 gets multiplied inside 7x square, minus 1 becomes 7x square, minus 7 minus 6, x square, 2x plus x gets added, and here we will get 3x plus 2 as it is. Okay, guys, and all the three factors, they are as it is. I am not rewriting it, but it is understood. Now 3 gets multiplied to these three terms. So we will get 3x square plus 3x minus 3 2s are 6, then followed by this 7x square minus 7 is as it is, then followed by 6 gets multiplied to these three terms inside the bracket. So we will get minus 6x square, minus 6 3s are 18x, minus 6 into 2, minus 6 2s are 12, whole upon, guys, the same, all the three factors which I am not writing, which are x plus 1, x plus 2, x minus 1 only. Now, as you can see here, 3x square minus 6x square and 7x square, if you solve 7 plus 3, 10 minus 6, it becomes what? 4x square. That way we can take care of this, followed by 3x when it is added to minus 18x. It will give 3 minus 18 minus 15 x square, now followed by minus 6 minus 7, which is minus 13, minus 13 minus 12, all the negative terms are added, which gives what, guys? Which gives minus 25 upon all the three factors, guys, less than 0. Now 25 into 4, if you see, which can be written as, we have to write it so that the difference is minus 15. So 5 square into 2 square, we can write it as a 25 into 5 4s are 20 into 5. So 20 minus 5. So that way we can write 4x square minus 20x plus 5x minus 25 upon all the three linear factors. And now we will take what, guys? We will take common from first and second, third and fourth terms, guys. So after taking common, what we will take common from first two? Yes, 4 we will take common. So we are left with inside what? X square. And let's take x common also, 4x. So we are left with x here into x minus 5. Now we will take 5 common from the third term. So we are left with x minus 5 upon all the three terms as it is less than 0, guys. So now as you can see, x minus 5, if you take common, inside you would be left with 4x plus 5. And now these two are the zeros. And now I will write the three poles, x plus 1 into x minus 1 into x plus 2. Now we have to plot them on the number line. So first we will calculate the zeros. Zeros we have to equate x minus 5 equal to 0. X equals to 5 is one of the 0. 4x plus 5 equal to 0. We will get x equals to minus 5 by 4 as the next 0. So 2 zeros we got. Similarly, the poles, we will equate x plus 1, 0. So we will get x equals to minus 1. Then we will equate x minus 1. So x equals to 1 is the another pole. Final pole is when we equate x plus 2 equal to 0, we will get x equals to minus 2. So 3 poles and 3 zeros we got. So plotting them on the number line, there are 5 numbers we need to plot, in which there are 3 poles and 2 zeros. So plotting the the biggest one is 5. So x equals to 5, we will write on the rightmost. So this is 5, followed by the next is, which is x equals to 1, which is a pole. So x equals to 1 we will write. We'll mark it by cross sign as usual, and then followed by minus 1. So minus 1 is the next pole, cross sign, minus 1 we will write, guys. Okay, and then again, guys, what next? Yes, the next is after minus 1, we will plot minus 5 by 4. Why? Because it is minus 1.25. So this is minus 5 by 4, which is a 0, followed by the last x equals to minus 2, which is another pole. Okay, so guys, now plotting them, write the rightmost interval by 5. All the powers are odd because all the powers are 1. So subsequent plus minus we will write plus minus, then again plus, from again minus 5 by 4 to minus when it is minus, again minus 2 to minus 5 by 4 it is plus, again minus 2 to minus infinity it would be minus. Now the question is asking for what, guys? Less than 0. It means negative. All the negative intervals would be a part of our answer. So minus infinity to minus 2 we will take, minus 5 by 4 to minus 1 we will take, 1 to 5 we will take, guys. So these intervals would be our answer that we can write in the interval form like this, minus infinity to minus 2. Okay, so minus infinity to minus 2 we wrote. Then we will write minus 5 by 4 to minus 1 using this connector, this minus 5 by 4 to minus 1 union the last, which is 1 to 5 interval, all in open bracket, 1 comma 5 open, would be our final answer, guys. Let's take another example. Let's try this question now. Let's take and use another variable just for this change sake. Y we are using instead of x minus 4 greater than 0. Find range of y, or find simply y. So how do we solve this, guys? So if you think, the hint would be like this. We will use x square greater than a square, and we know x square greater than a square means x is greater than a or x is lesser than minus a. So here x is what, guys? X is y plus 1 upon y minus 1 and a is 2. Okay, that way we can solve this. So in the next step we can write, this is actually, this question is this greater than 4. This value is greater than 4. So this 4 we can write greater than 2 square. So that's why I wrote a is equal to 2. So a is equal to 2 and x is, so a is equal to 2 and x is this. So we will write directly, we will solve these two inequalities, x greater than a, x less than a, and whatever the value of y comes, we will take the union or of them. So that's how we will proceed in our solution, guys. So solution is x greater than a, we will find, x less than minus a we will find, and then we will take the union of both. So x greater than a we will find, replacing x by y plus 1 upon y minus 1 greater than 2. Okay, now y plus 1, y minus 1, we cannot cross multiply y minus 1 here. Okay, we discussed, because we are not sure about the sign of y minus 1, so we will take 2 on the left hand side, minus 2 greater than 0. Now we will take LCM, guys. Y plus 1 minus 2y, okay, minus 2 bracket upon y minus 2 is greater than 0. Now in the next step, guys, y plus 1, we will multiply minus 2 to this. So minus 2y, minus 2 into minus 2 plus 4, it becomes whole upon y minus 2 greater than 0, guys. Now y and minus 2y, if you solve, you will get minus y. Now similarly, plus 1 and plus 4, if you add, you will get plus 5 upon y minus 2 greater than 0. Since if one of the coefficient or odd number of coefficients are negative, then we can start from the rightmost interval. We can start with negative sign. That way also we can do, instead of multiplying it by minus 1 and changing the sign of the inequality. This time we will do using this. Okay, so here the coefficient of y is negative, so we will take rightmost interval in as minus. It is how? So the 0 is minus y plus y equal to 0, y is equal to 5 is one of the 0, and pole is y minus 2 equals to 0, which is y is equal to 2. This is one of the pole. So we will plot them, 2 and 5 we will plot. Poles won't be apart, so we will mark it by cross. Now as I said, rightmost interval is 5 onwards, we will mark it by negative sign, because this is negative, minus 5. One of them is negative. If so, plus, and if odd number of coefficients are negative, that then also we can do this. So minus plus minus. it will come, guys. Okay, so the question is asking for positive. So positive is this, so we will take 2 to 5 as our final answer, guys. So 2 to 5 is our answer, both in open interval. So 2 to 5 is first answer. Okay, now the second answer, whatever we will get, uh, okay, x less than minus a we will solve, and x greater than a we already solve. Whatever we get, uh, both the answers we will take union or. Okay, so x less than minus a we will solve. So the second thing is x less than minus a. So x a was 2, so this is minus 2, and this is y plus 1 upon y minus 1, y plus 1 upon y minus 1 or y minus, oh, I wrote it minus 2 here. Oh, in the next step, instead of minus 1, I wrote minus 2 and I solved it. So guys, let me change the entire question. So guys, instead of minus 1, I mistakenly wrote minus 2. So let's change the question to minus 2 because we calculated using minus 2 only. So here minus 1 I will rub and I will replace it by minus 2. Minus 2 upon minus 2 y minus 2 minus 2. So y plus 1 upon y minus 2 is x. Y plus 1 upon y minus 2 we will take on the left hand side. So minus 2 will become plus 2 less than 0. So now taking LCM, y plus 1 plus 2 y minus 2 less than 0. Now 2 gets multiplied to y minus 2. Y plus 1 is as it is. So plus 2y minus 2 2s are 4 upon y minus 2, guys, less than 0. Y and y 2y gets added. It gives 3y, and 1 and minus 4 gives you minus 3 upon y minus 2 less than 0. So 3 y minus 1 upon y minus 2 less than 0. 3 we can multiply both sides by 1 by 3. So this is y minus 1 upon y minus 2 less than 0. We will plot it on the number line, guys. So y minus 1 gives 1. Y minus 2 gives 2. This is a pole. Y minus 2, this is a 0. Okay, the question again plus minus plus. Okay, 1 to 2 less than minus it is asking for, so this we will take. Okay, so this is the second one. The final answer is the union of what? Yes, union of first and the second. So the first one was, the first answer that we got was 2 to 5. Okay, so 2 to 5 open we will take, we will write here. So 2 to 5 union 1 to 2. Okay, so union 1 to 2. So union 1 to 2. That is the answer for this, guys. This is the final answer, 2 to 5 union 1 to 2, guys. Okay, let's take another example. Three upon x plus 1 less than equal to x minus 1 upon, x plus 1 less than equal to 2. So guys, how we can solve this, and what first let's understand the meaning of this. Once you are comfortable with the meaning, we will proceed with the hint. Okay, so guys, the meaning is this. See, a is less than b is less than c, a less than equal to b, b less than equal to c. If I write, in between what will come? In between x and will come. So the a less than equal to b less than equal to c means a less than equal to b and b less than equal to c, which means this. Let's say, for example, if you write x greater than equal to 2 less than equal to 5, and if I ask you find the intersection of x greater than equal to 2 and x less than equal to 5, you will get 2 to 5 only, guys. That's why you can write it like this. So once if you can use this, so the hint is quite clear. Hint is we have to use what? We have to solve these two inequalities and take the intersection of these two. 3 upon x plus 1, 3 upon x plus 1 less than equal to x minus 1 upon x plus 1, and x minus 1 upon x plus 1 less than equal to 2. These two inequalities we have to solve, guys. That's the hint. So moving on to our solution part. So let's say this inequality is first, this inequality is second. In solution part, we will solve first, we will solve second, and we will take the intersection of 1. So solving 1. So solving 1 first, which is 3 upon x plus 1, which is 3 upon x plus 1 less than equal to x minus 1 upon x plus 1. I will take this to this side. So in the next step, this becomes minus x minus 1 upon x plus 1 less than equal to 0, guys. Taking LCM, so x, you can see they are same, so denominator is same. So simply we can write it like this. Now 3 minus x plus 1, it becomes upon x plus 1. Sorry, this is not 1, this is 0, less than equal to 0. In the next step, it is 4 minus x upon x plus 1 less than equal to 0. So the 0 is, guys, the coefficient of x is negative. So as I said in the previous example, we can start the rightmost interval by which sign? Yes, which minus sign. So we will plot the 0 and the pole minus 1, and this is 4. Minus 1 is cross. Now minus plus minus, because the coefficient of x in this is negative. Even number of negatives, if they are present in the inequality, then they will neutralize. Odd number of negative coefficients of linear factors, if they are there, then only we will start with minus sign, guys. So minus plus minus. Now question is asking for negative, so we will take negative as our answer. Two negatives are there. One is greater than 4, another is lesser than minus 1, which is minus infinity to minus 1, 4 to infinity. This is the first one. Okay. Now the second one, we will take the second part, which is this x minus 1 upon x plus 1 less than equal to 2. This is the second part that we will solve. X minus 1 upon x plus 1. Second part, x minus 1 upon x plus 1 less than equal to 2, we will solve, guys. So again, as usual, taking 2 on the left hand side, it becomes minus 2. Taking LCM, minus 2 gets multiplied to x plus 1 upon x plus 1 less than equal to 0. Now x minus 1 minus 2 x minus 2 x plus 1 less than equal to 0. My x minus 2x gives minus x, minus 1 minus 2 gives minus 3, x plus 1 less than equal to 0. Again, one of the coefficient here has negative sign, negative coefficient. So again, we will start with the rightmost interval with negative sign. First we will calculate the 0, which is minus x minus 3 equals to 0, gives x equals to minus 3, and the poles, only one pole is there, x plus 1 equating to 0, x equals to minus 1 we will get. So using the wavy curve method, we will plot minus 3 minus 1. To start, we will start with minus sign, as I said. Okay, then plus alternate, because all the powers are 1, which is what? Minus. And then we will take the minus. So this and this is the second one. Okay, now we will take intersection of second with what? 1 to get our final solution. Now what was 1? 1 was minus infinity to minus 1 union 4 to infinity. So that we will plot here, minus infinity to minus 1. So minus infinity to minus 1, it is bigger than minus 3, so it would be on the right of minus 3, and 4 to infinity. So 4 would be bigger than minus 1. Just a minute, guys. Minus infinity to minus 1, it will be till here. Yes. And 4 to infinity, guys. 4 to infinity. So we will take intersection of these two. We will draw perpendiculars. Okay, as usual. Now we will take the common. So as you can see here and here, it is common. Minus infinity to minus 3, it is common. Minus 3 to minus 1, nothing is in common. Again, minus 1 to 4, nothing is common. But here, yes, 4 to infinity. Here also 4 to infinity is common. So the answer is what, guys? Their intersection gives you the final answer as minus infinity to minus 3 union 4 is not present in this. So here also open only 4 to infinity. That is the answer. X belongs to minus infinity to minus 3 union 4 comma infinity, guys. So that way we can do. Okay, moving on to our next example. X square plus 4x plus 4 upon x square minus 2x plus 1 greater than equal to 0. Solve for x. So how we can approach this? So what should be the hint? Hint is the same, guys. Factorize and use wavy curve method. Okay. So now let's see the solution. So x square plus 4x plus 4, as you can see, x square plus 4x plus 4 is a perfect square if you observe it carefully. So we can write it as x plus 2 whole square, because its discriminant is equal to 0. The similar way, if you notice, x square minus 2x plus 1 also, it is also a perfect square which can be written as x minus 1 whole square greater than equal to 0. Okay. Now the thing is, we can plot them. This is the 0 is clearly minus 2. The pole is 1. We will cross it. Okay. Mark it by plus. Now all the powers are even, so plus on the, while moving left, here also it will be plus. Again, if you move cross minus 2 towards the left, here again it will be plus only. So guys, the question is again also asking for positive or equal to 0. So equal to 0 would be provided when x is equal to minus 2, right? So we can write all real values from minus infinity to plus infinity. It is satisfying. So x belongs to R. Okay, all real values excluding 1. So excluding 1, we can write. Okay, so that's the answer to this, guys. Minus infinity to plus infinity excluding 1. What if the question would have asked for less than 0 instead of greater than equal to 0? In that case, what would have been the answer, guys? So since everything is positive, if they are asking for negative, the answer would be no solution, guys. If you think carefully, there is no negative here. So in case if the question asked for less than 0, the answer would have been no solution or x belongs to 5. Okay, guys, that way we can do a similar kind of problem, which is like this. If I ask you, what about the x square minus x plus 1 upon x square plus 3x plus 17 less than 0, what should be the approach? So the hint is, as usual, factorize. You will try to factorize, but the thing is, as you observe, we won't be able to factorize because the discriminant in both the case, in the numerator as well as in the denominator, is negative, guys. Since it is negative, what discriminant is negative? In the solution, if you see the quadratic in the numerator, the discriminant, let's say d1 b square, which is b square minus 1 square minus 4 into 1 into 1 minus 3 is negative. In the similar way, if the discriminant 2 of the numerator is negative, denominator is again b square minus 4 into 17, whatever it comes out, it is quite clearly it is negative. So since it is negative, both the expressions in the left hand side are positive always. Denominator is also always positive. They can never be 0 also, guys. Now the left hand side of the inequality is positive always, because denominator numerator is always positive. So if you impose a constraint, so this question, if you impose a constraint, since this question the left hand side is positive, okay, both are positive, negative is not possible. There is no such x for which this becomes what, guys? This becomes negative. Okay, so no solution we can say in this case, because whatever, even we cannot make it 0 also, because when discriminant is negative, provided coefficient of a, which is x square, is positive, the quadratic expression is always positive, guys. This is always positive for all x belonging to R. Similarly, therefore the denominator also, which is x square plus 3x plus 17, okay, this is also positive for all x. It can never be 0 also. So no solution, guys. That way we can say. So guys, try this question. We have to find the number of integral values of x. It means all those integers which satisfies this equation x square minus 2 upon x square minus 21x plus 68 less than 0. All those integral values, total number of integral values, that is what we call number of integral values, that we have to calculate. So how do we do this, guys? So the hint is obviously it seems like we need to solve this, right? So you factorize the quadratic, okay, factorize it and use wavy curve method, okay, factorize and use wavy curve, and that way you can do it. And then from the number line you have to count the integral values from the solution set, you have to count. So guys, let's do this, okay. So the solution as usual goes like factorizing first the numerator x square minus 2 equals to, we can write x square minus root 2 square. So a is using a square minus b square, you can write it as a minus b, a plus b. So x minus into x plus root 2. Similarly, the denominator, which is x square 1 minus 21 x plus 68, if you factorize 68, it is 17 into 4. So we can write 21 as 17 minus 4x plus 68. So x, taking x common, minus 17 minus 4 common, x minus 17. So the two factors are x minus 4 into x minus 17, guys. So x square minus 2 upon x square minus 21x plus 68, this inequality reduces to in the factor form x minus root 2 into x plus root 2 whole upon x minus 4 x minus 17 less than 0. Now we can plot it on the number line. Okay, so there are 4 values, 2 are zeros. So the zeros are x equals to root 2 minus root 2. The points at which the numerator vanishes, the poles are x equals to 4 and 17, the points at which denominator vanishes. So this is 17, this is 4, okay, and this is root 2 minus root 2. 4 and 17s are poles, so I will place a cross sign here. Now again the rightmost interval I will mark by plus sign, and then again it is minus because all the factors have power 1, okay. So again minus, this interval is plus, again moving leftwards this interval would be minus, again finally in the last interval it would be plus. What they are asking is negative. So for negative we will choose these two intervals, minus root 2 to root 2 and 4 to 17, guys. So this is the answer, but our answer, we need to find x which is integer satisfying this. So when in the first, this interval, when x is from minus root 2 to root 2, root 2 is approximately 1.2, okay, sorry, 1.414 it is. So it is 1.42. So as you can see here, x equals to, and this is minus 1.42. So x equals to, clearly minus 1 will satisfy, 0 will satisfy, and 1 will satisfy. So 3 values here in this interval we got. Now when x is, so guys, when x is between 4 to 17, that I will write here, when x is between 4 to 17, clearly x equals to 5 will satisfy, 6 will satisfy, till 16 it will satisfy. So if you count from 5 till 16, how many values you will get? 5 to 10, 6, and 11 to 16, 6, 12 values. So total integral values are how many? Yes, it is 3 plus 12, 15 values. Answer is 15. Okay, so that way we can do. So integral values are 15. Let's take another example. So guys, x cube minus 3x square minus x plus 3 whole to the power 5 upon x minus 1 to the power 7 less than equal to 0. So this is a cubic, and cubic we generally factorize by rearranging the terms, or by finding a root by factorizing the constant term. Okay, that's how we do, that's how we factorize a cubic. Sometimes directly by taking common, we can find out a linear factor out, and then the quadratic also can be factorized. Otherwise in other cubics, it depending on the constant term, we have to use hit and trial to get the factors, if at all it has real roots. That is something which is a part of a discussion in a chapter which follows it in quadratic and all. As of now, simply if you see this, if you simply take x square common from first term, so what you will get, x square x minus 3, and minus 1 common from minus x and plus 3, you will get x minus 3. So since this is rather simple, so one linear factor just came out easily, x minus 1 to the power 7 less than equal to 0. So taking x minus 3 out, guys, x square minus 1 whole to the power 5, denominator x minus 1 to the power 7 as it is less than equal to 0, guys. Now x square minus 1 is x square minus 1 square, which is a square minus b square. So a x minus 3 as usual, a x minus 1 into x plus 1, guys, whole to the power 5 upon x minus 1 to the power 7 less than equal to 0. Okay, x minus 3, now the power gets distributed in x minus 3, x minus 1 and x plus 1. Denominator as usual is same. So I can write it 7 as 5 and 2. The purpose of writing it as 5 plus 2 is this and this gets cancelled. As soon as you cancel these two, you make an assumption. It means that x is not 1, because you cannot cancel terms which is 0. 0 upon 0 we cannot cancel, it is not defined. When x is not 1, we can cancel both. So assuming x is not equal to 1, we can now further solve it. Now we have linear factors which can be factorized, which are already in factor form. So we will write the zeros are as usual x minus 3 equal to 0 and x plus 1 equals to 0. We will obtain one as 3, another as minus 1. The middle one is a pole corresponding to x minus 1 equals to 0, which is x equals to 1. So 1 is never part of a solution. Plus, minus. Now 1, the power is even. At 3, the power was odd. Okay. While moving towards left at 3, the power of 3 was 5. It was odd. So therefore plus became minus. Okay. Now further moving further at 1, where the power is even, which is 2, this sign now will be minus, will remain minus only. And now as you move further, cross minus 1 where the power is 5, which is odd. Now in this interval minus 1 to minus infinity, the sign will change and it will become plus. Now the question is asking for less than. So less than means negative, we have to take negative signs. Negative signs we have to take as our answer. So we will write it, we will take minus 1 to 1, and from 1 to 3 also we will take. Okay, so that would be our answer. So x belongs to minus 1 to 3, in which we will exclude 1. Okay, x equals to 1 we will be excluding. Okay guys.